Factorisation.com.
Next topic of real numbers is revisiting irrational numbers. Revisiting of irrational numbers. Irrational numbers can also represented on a number line. We can represent irrational numbers also on a number line. Therefore, irrational numbers are also in the set of real numbers, means irrational numbers are also real numbers. Now, we have to prove that root 2 is an irrational number. To prove root 2 is an irrational number. Prove that root 2 is an irrational number. This is the question. Prove that root 2 is an irrational number. The method here we are adopting is that first of all we may assume root 2 to be a rational number. We will assume that root 2 to be a rational number. Then in the last we will prove that our assumption was wrong. That means root 2 is not a rational number but root 2 is irrational. That is the method of proving. So first of all we are assuming that root 2 be a rational number. Let's root 2 be a rational number. What is a rational number? Rational numbers are numbers which can be expressed in the form a by b or p by q, etc. Every numbers which can be expressed in the form of a by b or p by q are called rational numbers. Then if root 2 is a rational number, then root 2 can also be represented in the form a by b or p by q, etc. Now we are assuming root 2 be a rational number, therefore root 2 can be written in the form a by b or p by q. Therefore root 2 is equal to a by b. Cross multiplying we are getting, therefore a is equal to root 2 into b. A is equal to root 2 into b. We are getting this step by cross multiplying, then squaring both sides. Squaring both sides, we are getting a square is equal to root 2b the whole square, which is equal to 2b square. That is, a square is equal to 2b square. We are getting the value of a square as 2b square. Since b is an integer, b square is also an integer. When an integer is multiplied with 2, it will become an even integer. That means 2b square is an even integer. That means this a square is an even integer, which is an even integer. Which is an even integer. That means a square is an even integer, therefore a must be also an even integer. Therefore a is also an even integer. Therefore we can write a as a multiple of an integer 2. Therefore a can be written in the form 2k, where k is some integer. Where k is some integer. K is an integer, therefore 2k is an even integer, because here we are getting a is also an even integer. Therefore we are writing a square to be 2k, where k is some integer and 2k is an even integer. Again squaring. Therefore a square is equal to 4k square. That means 2k the whole square. We are getting 2k the whole square, which is equal to 4k square. Here also we are squaring both sides. A square is equal to 2k the whole square, which is equal to 4k square. But we have the value a square is equal to 2b square. A square is equal to 2b square. So instead of a square we can write 2b square. That is 2b square is equal to 4k square. Therefore b square is equal to 4k square divided by 2. That means b square is equal to 4 by 2, which is equal to 2k square. b square is equal to 2k square. That means k square is an even integer. So 2k square is also an even integer. Since k square is an integer, 2k square is also an even integer. When an integer is multiplied by 2, it will become an even integer, which is even. That means b is also an even integer. Since b is an even integer, since b is an even integer, 2 is a factor of b. 2 is a factor of b. When we are assuming root 2 is equal to a by b, we have to give the explanation of a and b. What kind of numbers are a and b? Where a and b are co-prime integers. Where a and b are co-prime integers. A and b are co-prime integers. What is meant by co-prime integers? Integers which are having no common factors other than 1. That is the meaning of co-prime integers. We are assuming root 2 equal to a by b, where a and b are co-prime integers. Co-prime integers means integers having no common factors other than 1. That is our assumption. But here we are getting, since b is an even integer, 2 is a factor of b. We are underlining this statement and naming it as statement number 1. 2 is a factor of b. Again, since a is an even integer, since a is an even integer, here we are getting the statement a is also an even integer. Since a is an even integer, 2 is a factor of a also. 2 is a factor of a also. This is statement number 2. From 1 and 2 we are getting 2 is a factor of b and 2 is a factor of a also. That means 2 is a common factor of both a and b from relations 1 and 2. This is relation number 2. We are getting another fact that from 1 and 2, from statements 1 and 2, we get, what is our assumption? 2 is a common factor of both a and b. 2 is a common factor of both a and b. Both a and b. 2 is a common factor of both a and b, which is contrary to our assumption. It means opposing our assumption. Contrary means opposing. The statement 2 is a common factor of both a and b is opposing our assumption, means which is contrary to our assumption. 2 is a common factor of both a and b, which is contrary to our assumption that a and b are co-prime integers. 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 Our assumption was a and b are co-prime integers, but here we are getting a statement which is opposing or contrary to our assumption that a and b are co-prime integers. That is, our assumption that root 2 is a rational number is wrong. That is, our assumption. That is our assumption that root 2 is a rational number is wrong. Our assumption that root 2 is a rational number is wrong means root 2 is irrational. That is, root 2 is an irrational number. That is, root 2 is an irrational number. Irrational means it cannot be represented in the form a by b. That means irrational numbers are non-terminating and non-recurring numbers. Non-terminating and non-recurring numbers are called irrational numbers. They cannot be represented in the form a by b or p by q, where a and b are integers or p and q are integers. Here, first of all, we are assuming that root 2 is a rational number. Is it, if possible, root 2 be a rational number? If root 2 is a rational number, then it can be represented in the form a by b, where a and b are co-prime integers. That assumption is very, very important. We are assuming that a and b are co-prime integers. Now, we are getting this, from this relation we are getting a is an even integer, and from that we are getting b is also an even integer. Since a and b are even integers, 2 is a common factor of both a and b. 2 is a factor of a and 2 is a factor of b also. That means a and b are having a common factor, which is 2. But our assumption is that a and b are co-prime integers. Co-prime means having no common factors other than 1. 1 is the only common factor of a and b. No common factors are there. That is the meaning of a and b are co-prime integers. But here we are proving 2 is a common factor of both a and b. Therefore, that statement, this statement is, or our assumption is opposing to our statement where a and b are co-prime integers. That means our assumption that root 2 is a rational number is wrong. Therefore, the meaning is root 2 is an irrational number. This proof is very, very important. Either root 2, either root 3 or root 5. Any one of these can be asked for the board exam. So study very well this proof. Okay.